Hi again. Unit 7, Skill 5. This is Miss Wesley, and we're going to jump a little bit here and talk about lines now. So we've been focusing on circles and writing the equations of circles and centers and radii and all of that fun stuff. So now we're going to switch gears and say, okay, well, how do we justify if lines are parallel, perpendicular, or, in fact, neither? So that's essentially our essential question for today. How do you know if lines are parallel, perpendicular, or neither? So again, take a minute to jot that essential question down, and hopefully by the end of this video, you are able to answer that question by writing a nice, thorough summary in that summary box. So, one or two big things we need to know today. We can identify the slope, which we're going to refer to as m, and that should say the, but we're going to say y-intercept, which is our b, from a linear equation when it is in the form y equals mx plus b. So you've seen that before, used it a lot in algebra. So we know that m stands for our slope, and then b stands for the y-intercept. So we're going to love it when we get equations into y equals mx plus b form. If it's not, we're going to have to work it to get there. So, looking at what we have here. So, first examples here, we're just going to start off real basic. It says, determine the slope. Oopsie daisy. Let's get that back. Determine the slope of the following lines. So, all I'm going to figure out is what is the m value for each of these lines, and you're going to notice right away that these lines are not in y equals mx plus b form, so that is always our first step, is we have to get y alone. So, in looking at this, that means I'm going to have to take this 3x and move it to the other side. So when I do that, I'm going to bring down a negative 2y. Please don't lose that negative in front of it. I have a negative 3x, and then I have that plus 12 that was on the right side originally. Again, yes, the y term is the only term on the left-hand side now, but I don't want anything in front of that y except a wonderful 1. So meaning I need to divide both sides by negative 2. What that's going to allow to happen is the negative 2 divided by the negative 2 is going to turn into a 1. So I'm left with the y. What I have here, so negative 3 divided by negative 2. 3 cannot be divided by 2 nicely, so I'm going to leave my answer as a fraction, but the negative divided by the negative can and will turn into a positive. So I have 3 over 2x, but then on this side, 12 divided by negative 2, well, that's just going to leave me with a negative 6. So my equation is now in y equals mx plus b form. I want the slope. The slope, again, is the coefficient in front of x. So that means our slope of this line is 3 over 2. Okay. Please don't write 3 over 2x. That's not the slope. The slope is just the coefficient in front of the x. So that's why I wrote 3 over 2. All right, let's try this one on the right here. 5y minus 10x equals 25. Again, my goal is to get y by itself, so I'm going to take this 10x and move it to the other side. What I'm left with is 5y equals a positive. That should be a 10. Let's try that again. 10, a little bit better. 10x, and I have a positive 25. Again, I need to get y completely by itself, so this time around I need to divide both sides by 5. 5 divided by 5 is just going to leave me with y, which is what I want. Next, I'm going to have 10 divided by 5. This time that works out nicely, leaves me with a 2x. And then I also have 25 divided by 5, which leaves me with a positive 5. So again, we're looking for the slope. Slope is what's in front of your x, so the slope of this line is a positive 2. So if you're stuck on that, please call Miss Griffin and myself over right now before we get further in the video, but that should have been a little refresher from last year in algebra. Okay, before I jump to example 2 with the horizontal and the vertical lines, again, our main focus for today is how do we know if lines are parallel? Whoa, that was a really big highlighter. And how do we know if lines are perpendicular? So, actually, I don't really like that. Hold on. Erase. Okay, let's try that again. Let's just make a nice little box. So parallel lines. So remember, parallel lines look like this. You have two lines that are essentially like railroad tracks that they're never ever going to touch. So what you want to remember about parallel lines is that they have the same slope. That S didn't really show up well. Slope. All right, parallel lines have the same exact slope. That is why they will never ever touch. Whereas perpendicular lines, so those are lines that form a wonderful right angle. These have what we call negative reciprocal slopes. I'll show you an example in a second. All right, so a negative reciprocal slope, if I give you an example here. Let's say we had a slope of positive 2. Well, 2 can really be written as 2 over 1. The negative reciprocal of that, well, negative means if my original slope was positive, my new one would have to be negative. And reciprocal means to flip, so this would turn into a 1 over 2. Okay, I'll give you another example. Let's say I had a negative 3 over 5. First thing I have to do is change the sign. So instead of a negative, my answer is going to be positive. Instead of 3 over 5, I'm going to have 5 over 3. All right, so those are a couple examples. All right, back to what we were doing. So example 2, determine the slope of the following lines. Well, if I take a look at this line that I have here, let's see, I just want to make this a little bit bigger. So this line right here. All right, if I want to write the equation of that line, that line is a constant height of 3, so since it always has the same height, it's going to be a y equals 3 line. Well, and if I'm talking slope here, and we know slope is rise over run, I'm not rising at all. I'm walking at a constant flat surface or a constant height the entire time. So since there's no rise, this has a slope of 0. All right, how you can remember that, another little trick here for you. This horizontal line, you can turn it into a Z for 0. Okay. The line over here to my right, so this time, I'm just trying to get a different color. This line right here, straight up and down, that always has a horizontal distance of 2. So this is an x equals, sorry. All right, let's try that again. This always has a horizontal distance of 2, so it's an x equals 2 line. Well, if I'm talking slope here, I'm constantly would be going down forever and ever and ever and ever, so I'm not running at all this way. So this slope isn't possible. You can't have a slope that's a straight up and down line. So when we refer to what's the slope of these lines, we say the slope is undefined. So we have a slope of 0, we have a slope that's undefined, and again, how you can remember this one, another little trick for you here, this vertical line, turn it into a U for undefined. So those are just two special cases when you have y equals lines and x equals lines of just constants, horizontal or vertical lines. Horizontal have 0, vertical have undefined. All right, now let's get into some questions like you're going to see on your exam. All right, so here's kind of like the heart and soul of this lesson. It says determine the relationship of the following equations. So when we talk about relationship of equations, we're looking for, are they parallel? Are they perpendicular? Are they the same line? Are they neither? So our goal here and how you go about this is the first thing you have to do is you have to get the equations into y equals mx plus b. So that is step 1, okay? So looking at our equations that we have here, first equation, y equals 5x minus 4. Well, that equation's already in y equals mx plus b, so that saves us a step. I'm just going to rewrite it so it's a little bit bigger. If I look at my second equation, y equals 2 plus 5x, that's also in y equals mx plus b because y is alone, but I'm just going to rewrite it so that way the slope comes first, so the 5x, and then I have the plus 2. All right, so both of those are in y equals form. So now something that you can do is you can graph them on your calculator if you're unsure of what these would look like. So if I was to take a second and plug this into my calculator, y equals 5x minus 4, and then I made a second equation and said, well, y equals 5x plus 2, what I would notice here is that the first equation would look something like this, and my second equation would look something like this. Now mine aren't perfectly straight here, but what we're looking to hopefully see is that we have two lines that are never ever going to touch. And if you think back, those are called parallel lines. And now we're just going to say, well, why are these two lines parallel? Oh yeah, they have the same exact slope. So the first equation had a slope of 5. The second equation has a slope of 5. So the relationship that we're talking about down here is we say these lines are parallel. But again, you always have to back up your reasoning in math. This is because they have the same slope. Okay? Parallel because of the same slope. All right, so that's the first kind of example like we're going to see. Let's take a look at example B, and we'll look at what's the relationship between these new two lines. All right, so in this scenario, we have 3y equals 2x plus 6 and 6x plus 4y equals 12. So step one, always, 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 is to get them into y equals mx plus b form. So if I focus on the first example here, I have 3y. So yes, the y term is by itself, but I have to get rid of that constant in front. So what's going to happen? 3 divided by 3 would leave me with y. But then remember, I'm going to say, okay, well, what's 2 divided by 3? I can't simplify that at all, so I'm just going to leave it as 2 divided by 3. And then I have 6 divided by 3. That's going to leave me with a positive 2. So there's my first equation, and y equals mx plus b. If I focus now over here on my second equation, I'm just going to copy that so I have a little bit more space. So 6x plus 4y equals 12. So I'm going to take this 6x and I have to move it to the other side of my equation. That's going to leave me with a positive 4x equals, I'm going to put that negative 6 in front, and then I have plus 12. Ooh, that should have been, what did I mess up here? This should be a y. Hopefully you guys caught that. Okay, you see how easy it is to mix up variables or write down the wrong letter? Alright, so now I have to get rid of that 4 in front, so I'm going to divide both sides by 4. 4 divided by 4 leave me with just y. Now again, I have negative 6 divided by 4. So 6 can't be divided by 4 nicely, but if you type that in the calculator, you'll see that it can be simplified into negative 3 over 2. And then 12 divided by 4, that's going to leave me with a nice positive 3. And again, look at this. There's my x that I forgot. So here's my two equations that we have. Y equals 2/3 x plus 2. Y equals negative 3/2 x plus 3. So I'm looking at these, I'm saying, okay, don't have the same slopes, they're not going to be parallel. I don't really know what's going to go on, so why don't I plug those into my calculator? You can always use that to help you remember. So here's my little graph. If I was to graph that first line, it would look something along this. And if I was to graph the second line, it would look something like this. And I'm saying, okay, they're intersecting, and look at that. They look like they do, in fact, make a right angle, and that's not a coincidence, remember. They make a right angle because of their slopes. My slope here is a positive 2/3. This slope is a negative 3/2. So these slopes are an example of flipped and negated, or opposite reciprocal slopes like we were talking about on the front. So since they have the slopes that meet that flipped and negated criteria, that's going to lead us to determine that these two lines are, in fact, the relationship would be perpendicular because they have opposite reciprocal slopes. Right, reciprocal slopes. Okay? So again, if you see two slopes that are flipped versions of each other, one's positive, one's negative, that is your big clue that those two lines are in fact perpendicular. Okay? And again, if I'm going too fast, pause, stop, rewind, slow down, call us over if you got questions. I'm going to look at the last page for this set of notes, and we have two final examples. So, example 4, this one's called special cases. Wonder why. It says, for each of the following pairs of equations, get the equations into our wonderful y equals mx plus b form, sketch them, and then determine the relationship between the lines. So again, step 1 is always to get them into y equals mx plus b. So I'm going to take this 2x, move it over. That's going to leave me with a negative 3y. Again, please don't lose that negative sign. Minus 2x plus 9. I need to divide everything by a negative 3. All right. So negative 2 divided by negative 3, those can't simplify at all, but I can get rid of the two negatives because they'll make a positive. 9 divided by negative 3 would leave me with negative 3. So there's my first equation. Now let's take a look at that second equation. So I'm going to copy it over here so I have a little bit more room. 4x equals 18 plus 6y. Now, you have a choice here. You can either take this 18 and just move it to the 4x side, because then y would be alone, or if you're someone that really likes to see the y's on the left-hand side, you can move the 6y over here, then move the 4x over here. Totally up to you. I'm going to take the route of just moving this 18 over, because then if I do that, I can still just flip-flop the entire sides completely. So I'm just going to bring the 6y to the left, and then on the right-hand side, I'm going to have the 4x minus 18. All right, because again, everything's balanced. I just personally like to see the y's on the left-hand side. So now I need to divide everything by 6. So I'm going to be left with y, where's my pen? Y equals 4 divided by 6. Again, 4 can't divide by 6 nicely, but if you type in the calculator, you will get 2 over 3. X, and then I have negative 18 divided by 6 is going to leave me with a negative 3. So, looking at these two equations, y equals 2/3 x minus 3, y equals 2/3 x minus 3. If I was to graph them, I wonder what would happen. Hopefully you already have an idea, but 2x minus 3 is going to look like this, and the other 2x minus 3 is going to look like this. These are the exact same lines. Not only are they parallel because, yes, they have the same slope of 2/3, but they also have the same exact y-intercept of negative 3. So these are actually the same line. So that's the relationship that we have here. Same line. And the reason is because they have the same slope and same y-intercept. So that is another possibility when you are working with equations. So don't be surprised if you get the same exact line, because it can happen. All right, one last example here, and then we are done with this skill, and you can go on to your practice. So this says here, what's the relationship between x equals 7 and y equals 2? So I'm looking at these and saying, okay, there's nothing to rearrange, so why don't I take a minute and sketch them? Well, x equals 7 would be an equation, or would be a line, that is constantly has an x value of 7. So 1, 2, 3, 4, 5, 6, 7. So it looks something like this. X equals, 7. All right, y equals negative 2. Well, that's going to be a line that always has a y value of negative 2. So 1, 2, it would look like this. So now if I take a look at these and say, well, wait a second. One of them is perfectly vertical. One of them is perfectly horizontal. So this must be a case of perpendicular lines, which they are. So these are perpendicular. And our reason is because one undefined slope, because remember that's our vertical line, undefined slope, and 1, 0 slope. That was our horizontal line. So, because again, if you think about it, you have a vertical line, you have a horizontal line. Think of it like the ground and a wall. When you build houses, they better make a right angle, and that's what we have here. So, long story short with this one is you always want to get your equations into y equals mx plus b form. Check out the relationship between the slopes, and then determine if they're parallel, perpendicular, the same line, or you actually have, please don't turn me off just yet, you have this last case down here where lines that do not meet any of the requirements up above, they intersect, but they're not at a 90-degree angle. So if I was to give you one quick example of this, that could be an equation that says y equals 2x minus 5, and then let's say you have the equation y equals negative 3/4 x plus 1. If you take a look at these slopes here, 2x and negative 3/4, well, they're not the same. They're not opposite reciprocals. So what that means is that the lines are going to intersect, but they're not going to be at 90. So you might have something that looks like this. And again, I'm just totally weighing this here, so this might not be anything at all. Well, 2x minus 5 would look like this. And negative 3/4 x plus 1 might look something like, I want to draw it so they don't have a 90-degree angle. Like that, let's say. Kind of close, but not quite. All right, so that's also a possibility. So take all those practice problems, work through them, work with each other, call us over, and then take that CFU when you're ready. See ya.